Good evening, everyone. So today, my group on the study case report, we will discussing about the harmonic distortion and the voltage of imbalance. So in this topic, we will go through for our table content on the introduction and background, and then we will go to for the data analysis. Number 4, we will talk about the consequences to the society and the environment. And fifth, the design solution. Last but not least is our conclusion. All right, we may begin our presentation.
Okay, I would like to thanks ADIB for the intro, and then my name is NAAVIND Balan. My metric card number is 211291019. So I would like to say good evening to my doctor, and I will start my presentation on the titles on a harmonic distortion. Okay, for my part, I will be introducing about the introductions and the backgrounds of the power quality. For the first introduction is the renewable energy source connected utility grid for power generations to give a supply for the source, and it is the growing percentage of use applications of maintainable energy sources in the generation mix. The use of photovoltaic power plant of a renewable energy source that are readily available. These power plants are abundant, safe, clean, and derived from the sun. The enhanced voltage profile, low energy loss, such operating and maintenance costs, lower electricity bills, and less transformer step changes loading during the peak hours are way that photovoltaic power plants linked to the distribution network can progress the power system's performance. Power quality problems have a negative impacts on the distribution system, mainly on nearby loads due to the sustainable increase in PVPP integrations with the power grid. So for the continuity of power introductions will be the essential enforce stringent power intelligence restrictions regulation pertaining to the penetrations of distributions energy generators as to be followed. Conventional power systems are built with producing stations located distance from load center. The transmissions and distribution networks are used to conduit. In a typical conventional power system, there are no generating plants on the consume side of the network or in the distribution system. The impacts of installing large scale of PVPPs linked to the grid and studying power quality concerns such as harmonic and voltage inequality on the operation in the electrical network is crucial. Okay, for the next is the backgrounds of the power quality. For that, the terms backgrounds of harmonic distortion describes that unwelcome harmonic frequencies that exist in an electrical systems. The first background, and the second is the many factors including non-linear loads and power electronics and other grid connected equipments may produce these harmonics. The harmonics that is harmonic distortions that is present constantly in electrical systems, and it often causes power electronics or non-linear loads. When there are harmonic frequencies in the electrical systems that differ from the fundamental frequency, it may lead to a harmonic distortions and other problems. For example, decreased efficiency, increased heating in equipments, and interference with communication system persistent harmonic distortion on the electrical system, usually caused by a different source in the grid or associated loads. For the continual part will be the concerning my mitigation strategies by suppressing harmonic currents and voltage passive or active harmonic filters may be installed to reduce harmonic distortions. Using capacity is eliminate harmonic distortions and enhance overall power quality. Power factors corrections may be increased power factor. You may reduce the amount of harmonic distortions that enters the grid by choosing equipments with low harmonic emissions and making sure the system is designed properly. The harmonic distortion may be caused by variations in voltage, unbalanced load, and other problems with the quality of electricity. This will be ensure that electrical grid reliability and stability while minimizing the impacts of harmonic distortions on a connected equipments and system. That's all from me. Thank you, and I will like to pass to my partner.
So next I want going to present. My name is THEVAGAREN. Yeah. So I'm going to present about the analysis and the characteristic, the depth of analysis required and characteristic, power stages of the grid connected to three-phase single stage PV system model. In this study, we have taken from the solar panel from Pahang. So it includes PV array maximum power point tracking without boosting stage is used to extract minimum available power from PV array. We can see the figure. It consists of a capacitor and connected to the output terminal of a PV array. It's a three-phase VSI. It's controlled RL filter which is connected to low voltage AC grid and setup transformer connected to Malaysian grid. So this is the schematic of a solar power in grid Nepal. First is a photovoltaic, a capacitor, inverter, as we all know. This is a RL and transformer, and grid this one go to a distribution center. So in this study, it showed that inverter VSI is used proposed to design, execute the power conversion and control optimization purpose. And the harmonic distortion is a very important and serious problem in a power system. It is described as the distortion of the normal electrical voltage or current waveform and then adjusted from the original shape and characteristic, as we all know. And this problem is caused by a rectifier, power converters, transformer, and rotating machine, as well known as a PV system. So let's go for the other slide. And this is a THD calculation for the voltage and current. Here, this one represents as a voltage, and this one is a current. And therefore, we have an international standard IEE for as well. Malaysian also, Malaysian National Grid Standard also consists standard to related to power quality, especially THD. Here in table 1 shows as the odd and even number. Odd harmonics, we have this limitation 4% and 2%, and even is a 1 and 0.5%. Voltage distortion limit is a bus voltage 2.3 to 69 kilovoltage, individual voltage 3, and total these are the records we must follow. And the voltage imbalance is defined as a negative ratio and the positive voltage ratio. So this one is a calculation for the positive and negative voltage ratio. This one is followed as according to the IEE standard. Next, I will pass to one of our meet.
My name is Muhammad HAFIZUDDIN bin HALIDEN, metric number 211292551. Okay. So my part is consequences of harmonic distortion and voltage imbalance. So in this part, there will be 4, which I will be covering. One is sources of HD and VI, which stands for harmonic distortion and voltage imbalance, effects of HD and VI, analysis techniques, and mitigation techniques. So the source of harmonic distortion. Harmonic distortion and voltage imbalance are the two frequent power quality concerns that can impair the dependability and efficiency of electrical power system. The frequent causes of harmonic distortion and voltage imbalance are as listed below. One is rectifiers and inverters used to convert AC power and DC power or vice versa. 2 is cycloconverters, same thing as well. Third is renewable energy system, such as solar and wind power systems. So what are the effects of the harmonic distortion and voltage imbalance towards the... Okay, so harmonic distortion occurs when a PV system So specifically, we are talking about the photovoltaic system. Voltage or current waveform is not a pure sinusoid and instead has frequency components. This can cause issues with the PV system, which includes reduced efficiency, overheating, and electromagnetic interference. So analysis techniques. So harmonic distortion is estimated and identified using the methods below, and it is described as well as measuring techniques and the data processing. So one is time domain analysis using oscilloscope and waveform analysis software. Two is frequency domain analysis using FFT and spectrum analyzer. Three, harmonic analysis software such as Fluke, Venets, and All Power Sight. And then lastly is calculating harmonic indices using THD, IHD, and HF. And then for the mitigation techniques. So mitigation techniques, one of which is the best that we could use is active harmonic filter. It is made up of a power electric converter, a control system, and a sensor system. Then the sensor system measures the voltage and the current waveforms at the point of common coupling, PCC, and identifies harmonic distortion. The control system then provides a compensation signal, which is utilized to regulate the power electronic converter. So the mitigation techniques, what are the benefits towards the system? One, we can get improved power quality. They can significantly improve power quality by reducing harmonic distortion and voltage unbalance. And then next is reduce energy losses. By reducing harmonic distortion, AHFs can reduce energy losses in the system, resulting in cost savings and increased efficiency. And then third is increased system reliability, that it can help prevent equipment failures and reduce downtime by reducing the stress on the equipment caused by harmonic distortion. Fourth is flexibility and adaptability. This can easily be configured to adapt to changing system conditions and can be used in a variety of applications. And then lastly is compact and lightweight. The AHFs are often more compact and lightweight than traditional passive harmonic filters, meaning it making them ideal for applications where space is limited. So in conclusion, the active harmonic filters are sophisticated power electronic devices that can actively monitor and adapt your harmonic distortion in the power system that we use. They provide a variety of benefits, including higher power quality, lower energy losses, and increased system dependability. Thank you. Then for the next part, I will pass out to my next presenter.
Alright, thank you. Good evening. My name is Muhammad Adib bin Muhammad SABRI. My code is 2112-92549. So in this design solution, I will be covering two subtopics, which is design and calculation operation, and one more is the exit of the code. So first of all, I will explain a little bit more about the harmonic distortion on the design solution. So first of all, the issue of the PV of the power quality issue is that there is a large scale PV power plant linked to the Malaysia distribution grid were investigate using the MATLAB or Simulink. Other than that, the standard Malaysian of the total harmonic distortion standard at the PCC is emphasized, as it is the PCC is the point coupling component of the located between the transformer and the electrical grid. Is crucial that ensuring the minimal THD impact on the other equipment. Other than that, this voltage and current will be shown later on the calculation. There is a three level of THD, output of voltage and the current waveform at a fundamental frequency of 50 Hz. As a result, the THD result at the SCD using the G1000 ohm. As for the temperature is 25 Celsius, shows that the voltage and the current waveform on oscillating. Here is the equation of the harmonic distortion, showing that the ITD of exceed of 5%, whereas the voltage of THD falls below the 5% restriction set affect the regulation. Despite of this implementation of FC equal to ohms C over 2 pi equal to R over 2 pi L Hertz. So showing that there's the implementation of a 3 level of voltage and the source of the inverter and the effective current management. So this total of harmonic distortion still see as a specific limitation. In order to address this problem, the RL filter is in a PV inverter which shows that carry a frequency of the PWM, whereas the parameter employed the compute harmony of subspecies of 1.5 ohm on 0.1 millihertz. Respectively, at the switching frequency of the 2000 hertz has been given on this equation. So the first waveform will be showing that the total harmonic distortion waveform at the STC of before filtering. As you can see, the difference here is exceed of 5% and also below 5% of THD. So figure 1.5 shows that the highest point is for the 38 point, and however the figure 6 show like highest on nearest are the same as figure 5, because then when it decrease, the distortion of the negative side shows much more likely more than the figure 6. This is because the parameter of the parameter at the fundamental of 50 hertz of the harmony order. So next up, the THD level waveform of STC is after filtering. So when after filtering, THD on 0.74, the THD on the figure 8 is 0.15. So there is a 5% difference on each of the harmony order, showing that the frequency had a different range of harmonic unbalance, whereas the comfort of the standard particular of this waveform previously noted on the point of the connection between the PV power plant on the utility grid known as the PCC. The PCC is positioned between the transformer and the electrical grid and the simulating model. To ensure this negativity effect, the requirement of the connected to the grid of the PV system output should be minimal for the THD value for the both voltage and current. As of, we will move to the next waveform with the implementation of the RL filter, which before and after the RL filtering here is much more noisy on before implementation, but when you put the filter on, you will see the waveform is much clearer and much more better to identify the reading. For that, distortion was high because obviously the prior of the filtering demonstrating on the part before constantly, and B was shown as result is an increase of the PWM carry off frequency using the suitable RL filter. The current waveform also shape as a smoother than the part before, because the FTT find that demonstrate that the compare of pre-filtering example for the 5 and 6 earlier were waveform of the 7 and 8 had the less THC and indeed as extended limits. However, on the next one, on 10 and 11, showing that the current and the voltage of the THD value of the PVPP and the PCC were insulated for 500 Hz, where the irradiation was value ordered for the TND to connect the Malaysian grid for under various level. So this solar irradiation value for the VTHD was said that clearly that constant was constructed in the figure 6. Therefore, the situation for the GCPP working under the various sign of radiation, one may conclude that the ITHD study on more significant than the voltage THD analysis. Furthermore, the operation was a lower solar irradiation than the higher irradiation level. Because of that, injecting more current harmonic into the utility of grid. Now, for the second subtopic, will extent of the application code. So here, the voltage of the imbalance factor shows that the photovoltaic power plant on the figure 12 is on the standard side of testing condition. However, on the 13 figure shows that it was connected to 500 watt, as I mentioned earlier. So this total harmonic distortion will increase compared to 1000 watt due to the fact that produced for this current voltage were lower than the value rated, resulting for the modulation index that is less than 1. In order to demonstrate the effective of the subject approach, individual harmonics also we compare that this two of the magnitude of the for every current harmonic of figure 7 until 10 will correspond of the range or indicate on table 1 earlier as Teva mentioned. Similar will compare in the magnitude of each individual of harmony on 8 and 11, which correspond on the specific table as table 2. It was determined on the not just individual harmonic exceed in specific in limitation. Next, I will pass on for the conclusion to AQIED. Thank you.
Thank you, ADIB. For my part, I'm going to talk about the conclusion. My name is UBAIDUL AQIED bin BUSTAMAM, student ID 2012922746. For the conclusion, I'm going to highlight our analysis of harmonic distortion and voltage imbalance to 3 key points, which is harmonic distortion, voltage imbalance, and overall recommendation. This is critical for the stability and efficiency of our electrical power system. The analysis of harmonic distortion in Pahang reveals several critical insights that are essential for maintaining the stability and efficiency of the electrical power system. The presence of harmonic distortion is primarily attributed to nonlinear loads such as power electronic device and industrial equipment. The harmonic distortion can lead to several problems such as overheating of equipment, reduced efficiency, and potential damage to sensitive electronic device. Mitigating this harmonic is crucial for ensuring the longevity and reliability of the power system infrastructure. Voltage imbalance, on the other hand, is typically caused by an uneven distribution of loads among the three-phase power supply system. This imbalance can result in negative effects such as increased loss in the system, reduced efficiency of electrical equipment, and also potential overheating of motors. Addressing voltage imbalance involves careful load management and potential infrastructure upgrade to ensure a more even distribution of electrical loads. And finally, for overall recommendation, addressing both these issues, which is harmonic distortion and voltage imbalance, is vital for improving the overall power quality in Pahang. This involves implementing appropriate mitigation techniques such as the use of harmonic filters, load balancing strategies, and continuous monitoring of the power system. By doing so, it is possible to enhance the efficiency, reliability, and safety of the electrical power system, which can benefiting both consumers and utility providers in the region. And that is all from me. Thank you.